friends, welcome to my channel Animated Study. In previous video, we have seen about depth first search, in which we have going to the depth of the graph until and unless you are getting all visited node or the dead end. Here we will see the another algorithm, that is breadth first search, in which we can start traversal of the graph from any node and then we will explore the adjacent node and then traverse the node level by level. So in breadth first search you start to traversing the graph using any node. Suppose here we start from A node, so we'll take it as a level 0, then you explore the adjacent node of A, that is B and D, so that is on level 1, so we will traverse the level 1. Then we are moving ahead to the second level of A node, that is E and G, so we will go to the level 2 and at last we will explore the third level, that is H. So in breadth first search we will start from the any random node and then we will explore the first level node and then we are exploring the second level node and then we are exploring the third level node and so on. So we will see how the breadth first search works using queue data structures. So here we have a graph with some random nodes S, B, D, E, F, G and H, and we are taking the queue for breadth first search traversal. So we will start from any random node. Here we will start from S. So we will take S into the output and we will insert the S into the queue. So we will mark S as a visited node and we'll increment front and rear pointer by 1. So it is now on 0. Now we will delete the S from the queue. And once we delete the S from the queue, adjacent node of the S, those are B and D, we will mark as visited and put into the queue. So here we will increment rear and front pointer. So now you can see in output window you have a S, B and D. Those are the visited node. Now again you delete the front node from the queue, that is B. So once you are deleting the B, its adjacent node, that are S and E. S is already visited. So we will insert E into the queue and mark E as a visited node. So you can see here in the output. Now from the queue you take the first node and delete it. This time it is D. So the adjacent node of the D, those are S and G. S is already visited, so insert G into the queue from the rear side and you increment rear by 1. Now again you delete the front node, that is E here. So when you are deleting the E, its adjacent node, that is B and H. B is already visited, so you insert the H into the queue. Now you can see H is visited, so H is in output list. Now you delete the front node from the queue, that is G here. For the G you have a two adjacent nodes, those are D and H. Both are visited now, so no need to insert anything in the queue. Now you delete the remaining node, that is H, and once you delete it you set the rear and front to the -1. And since you have deleted H, its adjacent nodes, those are E, F and G. Here E and G are visited already, so we will take F into the queue now. So you can see here that is marked as visited, and here you can see in the output F. Now from the queue you delete the F and you set rear and front to the -1. So when you have deleted F, its adjacent node, that is H only, and that is already visited. So no need to insert anything, and at last you can see entire queue is empty and you have visited all the node, and you are getting the output sequence, that is S, that is on 0 level. Then you have visited B and D, those are in the first level. Then you have visited E and G, those nodes are in second level. F is not in second level because it is 1, 2, 3 and 4 level away from the S node, so we will not take it into the second level. And you have explored the H, that is in third level, and at last you have explored the F, that is on fourth level. And in this way you have level by level explored the node in breadth first search fashion. So this is all for BFS Traversal. So if you like this video, please subscribe my channel and share the video, and don't forget to press the bell icon for my new video notifications. Thanks for watching.